Is it recording? Yeah, looks like it's recording. Okay, hi. So today I'm going to be trying this contest, which is 841. A subscriber said that the problem of this contest is interesting, so I thought I'll just try the whole thing. So yeah, as usual, I'll start with A. I have 15 minutes to do whatever, and then look at stuff, and then try B again, 30 minutes to do whatever and look at stuff. So let's go. Hopefully I remember to keep sharing the right screen, and hopefully I also think about what to do about this later. Okay, let's go. Retest. I see. Okay. You should checking that this is exactly what is sharing. Okay. So yeah, the problem is you have an array of at least 2 elements, all positive integers. You can pick 2 elements in the array. Let's say, for example, I have 6 and 2. You can pick any 2 elements and you can replace them such that the products are the same. So for instance, I can make this 3 and 4, right? And I should do this such that the total sum of the array is maximized. So for a given product, I believe the sum is maximized when, like, for instance, if I have 1 into 12, I get 13. Sorry, it's 12, but 1 plus 12 is 13. So I believe sum is maximized when you just do 1 into the number. Like, take any two numbers that aren't, so like 6 fours are 24 instead if you did 24 into 1, right? Yeah, that's that you can show, I believe, like for a fixed product, like A into B equals C. If you fix C, then the maximum sum will happen when it's 1 comma C. Okay. Okay, let's look at some examples. 3, 2, 3, 2. So the first test case is 2, 3, 2. Oh, can you just show? Can you just multiply everything and then add 1? Is that it? 6 2s are 12 plus 1, 13. Oh, and it's multiplied by 20, 22. I think that's it. Why do I say that I am, and then doesn't exceed 10 to the 12. Yeah, I don't even need to, I can see the answers here. Oh, sorry. Yeah, sorry, not plus 1, that's plus n minus 1. And the reason, okay, assuming that we've shown between any two numbers, it's into 1, then what about like, yeah, I feel it's just product plus n minus 1, but I don't know concretely why I say that. So between any two, I maximized sum. Then between these two guys, say I maximized sum. Then I maximize sum. And then between these, yeah, it seems okay. I will code this up. And you have to multiply by you share? Okay, I'll share my desktop. Why is this? Okay, if you want to share multiple. Do you say control? Shared. Okay. Both are being shared. Yeah. Um, mm, I can actually. I don't need to store, no. Why do I want to do that? Autodesk, isn't it? Two, then three. I don't even know what this is. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1. So that's the alarm. Oh no. Why do I see problem tags? Oh, I haven't entered. I Yep. New share Chrome. Okay, you should be seeing my Chrome. Choose file. That was fine, but I would like to look at the editorial anyway. I feel like I most definitely didn't think. What is the maximum? Yeah, that was fine. Why is that the case? How do I show that um the maximum of a plus for a fixed constant value? The maximum sum is, I mean, I imagine if I graphed it, I would see it. I don't know why that's the case. Hmm. Yeah, so you have A plus B is equal to some constant. Oh, sorry. AB is equal to some constant, right? So B is equal to C by A. So A plus C by A. What is the max value? Yeah. Minus C by A square. So I have, what am I doing wrong? So I know to get the max value of this, or this, oh, this doesn't work. Oh, this gives me like the minimum value. So C, so then so okay, the zeros are at C equals A square. And I'm looking for like integers. So positive, like if I'm only looking for positive, one sec. That's fine. Max value. So I have these two like values. Then what do I do? I find the second derivative, which is C by A cubed. So if A equals plus root C, this is a maxima, a minima. A equals minus root C. This is a maxima. How does this graph look? I would say roughly. A plus C by A. Infinite. Then at 1, it looks like 1 plus C. At 2, it looks like 2 plus C by 2. And so on all the way till C until it reaches. So it's kind of like this, right? Reaches C. And then like after C, if A is C plus 1, C plus 2, and so on, it goes on till infinity again, right? So this is how this looks. And the negative side, I expect it's the exact same graph negatives. So this is how this looks. And hence we have a minima here and a maxima here. And the problem with this question was they asked us what is the maximum value of a plus b, not the minimum. And just because we know that it's integers from 1 to it's integers, so if it's 1 and c, right, like those are the cutoffs, otherwise you will have non-integral values. And so because we know that, we know we know how this graph looks, we can say it's 1 plus c. Nice. I hope this was shared. So yeah, only because it's integers, and this is the minima. We have this. Yeah, I think this I can remember. There's also, I think, I don't know whether the same idea can be used for a constant sum, but maximum product, and that's like the opposite, right? I just somehow know these things, but I never. So if a plus b is a constant and you want the maximum product, c minus a, so a times c minus a, right? So oh, sorry. C by 2. Here there are no two, there's no like two cases, it's just a is equal to c by 2. And here I assumed, both cases I'm assuming hmm. So how does this look? Um, is Yeah, what happens if A is negative? Oh, I see. Then the product's always negative. Okay. So at A equals C by 2. Okay, at A equals 0, I have 0. At A equals, I don't know, 2C. Okay, at A equals C, I have 0. And A equals minus C by 2. C plus C by 2 times C plus C by 2, 3C by 2. By 3 by 4 C square. So it's not symmetric. Like this part is much steeper. And it just goes minus 3C. Nice. I feel like these two graphs are useful to remember. Let me check on this more. Let me check how both of these look. And I guess I need to keep some random constant for this. So let's say x plus 10 by x. Yep, this looks right. And y equals x into 10 minus x. Okay, yeah, this also looks right. So, yeah, this is how it looks. Okay, I guess it's useful to remember this. So I'm just going to add this to my flashcards. Give me a second. So I'm currently sharing the desktop screen. Okay, So consider a product of two numbers for a constant sum. How does the graph? So I think the question here was sum of two numbers for a constant product. Um, X plus 10 by X for a constant force. How does graph of two numbers with a constant, graph product of two numbers of constant X time. Yeah, I don't know what like the optimal sort of time you spend, like from what you learn from each problem should be. Yeah, right now it seems like I'm spending a lot, but I guess that's what'll happen in the beginning, although it's not entirely the beginning. Yeah, I want to see what happens if. So here, let's say 12. And we know this minima happens at 7. No, sorry. 3 into 4. Oh, it's a root 12, root 12. Okay. Let me make this 16. Oh no, what am I trying to do? So if the product is 16, then I know the maximum sum is 7. Sorry. The minimum sum is 8, right? 4 plus 4, 8. I don't know what I'm trying to do. Okay. Um, but anyway, that was the first question. That was pretty good. Yeah, I'm just going to look at the editorial. I don't think there's much I can look at. P plus n minus 1. Oh, yeah. Yeah, they're saying the same thing. I don't know how I would explain it. Yeah, I'm just going to think about it later. Okay. Now we do the next problem. And I'm going to stop sharing for a second. Now I'm going to share screen again. Yep. Okay. We have 30 minutes for this. Hey, Google, set an alarm for 30 minutes. Okay. Kill demo dogs. Kill demo dogs. Okay, whatever that is. Ooh. Oh, the first one was Friends. This is Stranger Things. I see. Interesting. From the Upside Down have attacked Hawkins again. Elle wants to reach Mike and also kill as many in the way as possible. Hawkins can be represented as an n cross n grid. The number of demo dogs in a cell at the ith row and jth column is I into j. Okay, nice. L is at position 1, 1. She has to reach n, n. The only directions she can move are right, ij to ij plus 1. What is I and what is j in this? Yeah, okay, fine. So I is the rows, j is the columns. Yeah. Yeah, that's what they say. Okay. So same ij plus 1 and from ij to I plus 1j. Okay. She can go right and down. She can't go out of the grid as there are doors to the upside down at the boundaries. Oh no. Calculate the maximum possible number of demo dogs she can kill on the way, considering she visits. Okay. Yeah. You want to find the path with the maximum sum, correct? What does it look like? 10 to the 4 test cases. Oh, it's not random numbers in the grids. It's all of the numbers are I times j. Okay, yeah, thank goodness. Because it's a 10 to the 9 cross 10 to the 9 sized grid. The first line contains number of test cases, 10 to the 4 test cases. Okay, I feel like you literally need to just know the number. (2022) into aunts modulo 10 to the 9 plus 7. Okay. I think it feels like a bit of what we did in A is being used here. Let's think. 2, 350. Yeah. Okay, let's try to think without drawing it. Okay, let's say you have a 4 cross 4 grid, right? So it's symmetric, first of all, and it is 1 into 1, 1 into 2, 1 into 3, 1 into 4. That's the first row. I guess the diagonals have the same sum. But I feel like you want to get into the last column quickly because that has all the big guys. What, no, is that not what you want to do? Okay, would it be fair to say just going down the diagonal is best? Sigma I is equal to 1 to n I square. I don't think so. Let's look at the test cases. Oh, you can't go down the diagonal, sorry. You can only go left and right, right? You can go right and down, right and down, right and down. Diagonal plus these guys. Is that fair? So that's why it's, for this, it is 1, 2, 4, 2. And for the 4 case, it looks like, let me just draw this. 1, 2, 3, 4. Again, I have a hunch, but I don't know why. Okay, let's see. So I know that the sum here is 4, for example. The sum here is no. It's all increasing. What about for 3? These problems feel like I should be getting them immediately, and I think that's what prevents me from getting them immediately. Because sorry. Oh, right. It's the same thing. That's interesting, right? Yeah. It's all of these are like parts of each other. So I would, according to my strategy, it would be 10, 20, 22. So 22 into 20, 22. It's 44484, which is correct. But why? Okay, how would I? Okay, let me spend some 10 minutes trying to prove this is the case. And then if I can't, I'll just code it up and prove. Okay, what do we know about the sums? This increases by +1, sums increase by +1. I think it would be fair to say that the sums in these, ah, yuck, sorry. It would be fair to, be nice if I could write. Okay. Sometimes it's funny how my journal like imitates actual writing to the extent of also the pen not working. Yeah, I think it would be fair to say these guys have the same sum because, for example, this is 1 plus 1. This is 1 plus 2. This is 2 plus 1. This is 1 plus 3. 2 plus 2, 3 plus 1. This is 1 plus 4, 2 plus 3. Yeah, because yeah, it makes sense because I decrease j and increase I. So I decrease j and increase I by 1. So these guys all have the same sum. Okay. That's good. Is it fair to say that in my path, I will have to pick one guy from each of these diagonals for sure? Yeah, I think this you can show by induction. I think like if I'm here, right, I have to go here or here. So I definitely need to pick one of these. And if I'm in one of these, I need to go here or here, here or here. So I need to pick one of these. And if I am here, in here, I need to pick either this or this or this one of these, and so on. So as long as I'm on some diagonal, I need to pick one guy on the next diagonal, right? And from what we just learned, from problem A, which is awesome that like the whole thing is transferring. If the sum is constant, then the best product is like, oh, sorry. I'm sorry, what am I even saying? Oh yeah, no, I'm right, yeah. So the best product is in the middle, right? So you want to get the best product. So in each of the diagonals, if there's a way to get the middle or like, I guess, something close to the middle, you want to get it. And yeah, this way it does that. I like that proof. I think that's a fair proof. Now, how do we compute these sums? So this is also, I think, a nice thing to remember, which, yeah, after I finish, submitting this problem, I will write down what I need to remember. But so what are we doing? Yeah, sigma I is equal to 1 to n I square. I don't actually like using I because it feels like complex numbers, but that's okay. Thank goodness those are not here, so there's not that confusion. 1 into 2 plus 2 into 3 plus 3 into 4 plus sigma equal to 1 to n minus 1 I into I plus 1. Okay. So this is equal to, I can write this as n square plus sigma I is equal to 1 to n minus 1 I square plus I square plus I is equal to n square plus 2 sigma I is equal to 1 to n minus 1. See, I know I need to eventually use the formula for sum of the first n squares, and I'm just like postponing this because I don't remember that formula like at all. I think it's by 6 something. I know there's a by 6 somewhere. Let's see if I can remember it somehow. Plus n minus 1. No, sorry. Plus sigma I is equal to 1 to n minus 1 I. Right? So this is equal to n squared plus n minus 1 into n by 2 plus this. What is the sum of the first n squares? Is there any way I can think about what it is, or do I need to look it up? Let's see. 1 square I don't know why I remember n into n minus 1 into n minus 2 by 6, I think. I don't even know. Let's just try. If this works for the first like 5, I'm just assuming it's correct. Or, oh, sorry, is it? Yeah, it's n into n. Yeah, this would make more sense. So n is equal to 1. I get 1, 2, 3, 6. So that's 1, which is correct. N is equal to 2. I need n is equal to 2. I get 2 into 3 into 4 by 6. 3 4s are 12. 2s are 24 by 6 is equal to 4, but I need a 5. Two into 3 into 4. 1 plus 4 is 5. Yeah, screw it. I'm just looking up the first. Or I don't know if there's a nice way to remember it. I'll think about it after. Oh, I was close. N into n plus 1 into 2n plus 1 by 6. Okay, so it is n, yeah. Yeah. What am I sharing? Yeah. But it's always n minus 1, right? So it's n minus, but the whole thing for n minus 1. So but for n, it's n minus 1 into n plus 2 into n minus 1 plus 1, 2n minus 2 plus 1, 2n minus 1, 2n minus 1 by 6. Okay. So this is what I need to be submitting. And this whole thing into answer mod mod. This is what I need to be submitting. Okay, let's code this. Hmm. I will now share desktop. And also yeah, it's modulo 10 to the 9 plus 7, 10 to the 4 test cases, that's fine. 10 to the 9, the grid size. I'll make that LL and I'll make Hans LL and do as many mods as I can. Okay. just said LLN, CNN, LLN is equal to n square should fit with no issue. Yeah, 10 to the 18. Pretty sure LL. I forget. Let me look this up. I wanted to look this up last contest as well. Last. Long range. I need 10 to the 18, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. It's 10 to the 18 is okay. 9 and 0. Or do I need like extra? Do I need unsigned? How do I know? Because what I will be doing here, yeah, the alarm rang. But I guess the worst case is 10 to the 9 into 10 to the 9 plus 2, which seems fine. So, okay. And I need to remember long. Okay, let me not forget. I'll just put that in long range. Range. Mod plus I need to do by 2 in mod. That means I need this one's inverse, and I need 6's inverse. Oh gosh, this is something. So I think I have inverse. No, I don't. And like the way, or can you do it without? Can you do this without doing inverse? I mean, as in, okay. Let me. Okay, the issue which I can explain is the following. So I'll be doing all of this arithmetic under mod, right? So which means I need to, like, by 2 is essentially the inverse of 2 under mod. But that's annoying. So at least for this, I know one of them, and like I know like finding inverse takes a bit of work because yeah. What do I need to do to find inverse? I need to do exponential. I don't even know what I need to do to find inverse. Oh, I need to use that Fermat's thing. Yeah, let me at least go over how we find inverse. Oh gosh, this is the wrong. So we know for a right. So imagine you take 5, 3 to the 4, sorry, 1. Imagine you take, yeah, 2 to the 4, yeah, 4 to the 4, yeah. So you have this, so a to the p minus 1 is essentially 1. So for a, when you multiply it by a to the p minus 2, you get 1. So this is under mod. So inverse, this is Fermat's theorem. Something theorem, I forgot what. Right? So the inverse of a is a to the p minus 2. But to do this whole thingy, you need to do, you can't keep multiplying up to p to the p minus 2, so you have to do repeated squaring. And I think I have the code for that. So I think that I will just use. I had a really nice way to remember this. Yeah, I need to be going soon. But yeah, I need to think about this a bit. Like, it just fell out so easily. Like now I'm basically doing it from memory, right? But like this formula fell out like really easily. But anyway, I need to do to the p minus 2. Yeah, I remember this now. Okay, I will share desktop. I'm basically looking. Okay, so I think I would have tested that, so that's fine. Okay, now what am I doing? I'm calling that right. Yeah, LLX mod minus. Okay, now what all do we need? This I will move. N minus 1 into N mod into inverse of 2. Yikes. Mod. I don't think if I add, yeah, no, if I add 2 things, I don't need to worry about it exceeding, so I won't. Plus, this is the even N minus 1 into N Mod, mod. I need to learn how to go to the beginning of the word fast. And mod into 2 times n minus 1. I hope I didn't make any mistakes. Mod. Is this the whole thing multiplied by the whole thing multiplied by 2022? Okay, so that's n. Oh, I forgot the inverse. N minus 1 into n. Yeah. So what have I not like how to get to the beginning of the word, end of the word fast, right? Those two things. How to get beginning word fast insert notes. I don't know how to do that. Into 2022. So first n minus 1 times n, then I do a more, right? Times 2n minus 1. Then I do a more times 2022. Oh shit. 2022 is supposed to be oh I'm confusing myself. Okay. Through the 2022, we'll do that in the end. I think I can just do this. The whole thing more, and this is essentially this. I think it's fine. So n minus 1 times n mod 2n minus 1 mod inverse of 6 mod, and then the whole thing mod. Okay. This is fine. it gives me some ugly things. I won't even know what's the problem. What? First thing is 14157, right? I should have checked for 2 at least. N square, that is 4 plus 2 into 2 minus 1, that's 1, plus 1 into 2 into 3, 1 into 2 into 3 by 6, 1, 4 plus 1. Oh, 2 times I square. Okay. So I just need to do inverse of 3. Come on, see. Wait. Oh no, I'm in Zoom. Yes. Yeah. Oh, okay. 171010650. Yeah. 1. I think this is 10 per, right? Yep, that looks fine. Choose 5. Okay, so that's good. Now we go to tutorial. Shit. I just saw this problem's rated at 1100. Damn. I wonder how long I've been taking for. Oh, I see. We didn't have to do the whole inverse thing. 2022 is a multiple of 6. Damn. So that's what I missed. So that's why they gave you. I mean, they randomly gave last time also. I wouldn't have noticed. But I guess like people would have noticed. I wonder how many people noticed. Oh, okay, they gave some submiss. Sorry. Nice. So the whole inverse thing that I was worried about, I didn't have to. I could have just multiplied by whatever, 2022 by 6 instead of searching for my inverse code for a bit and things like that. So they have a different proof for why the zigzag is the maximum. Um, let's go over it for a bit. So my proof was that the non-principal diagonals all have the same sum, and you need to visit one element in each non-principal diagonal at least once. And if you can do it zigzag, you are visiting the guy with the maximum product in each non-principal diagonal. So you're definitely getting the maximum. But these guys, let's see. Let me attempt. I don't know if I'm sharing the right screen. Yep, I am. Let me attempt for a bit to understand this. And then I'll have to scoot, but I feel like I still don't do rows and columns well in my brain. I n minus 1. So I throw n minus 1th column, and they are constantly moving. Oh yeah, okay, fine. So okay. Okay, I read this for a bit. Let's try to understand. Oh gosh, I have like 5 minutes, I think. Not even 5. Okay. First, let's define the terms they have here. So, oh, is that how I get it to work? Or, yeah, I think I'll have to look at this offline. There's just, um, it'll just take too much time. But yep, that's it. Thank you.